In this episode, we're going to take a look at the Candohm resistor and calculate the wattages. Ouch! Let's take a look at this Candohm resistor. The center tap of the transformer comes over and it connects to the negative of the number 45 here, and it also goes to the end of the Candohm, which is, this end is 202 ohms, and then the next section is 8 ohms, and then the side that's going to ground is 35 ohms. So let's take a look at this. So let's put it to ground, and I believe this end is the ground end here. And if you see, it's 0.5 ohms, so we know this is the ground end of it. And so the first one should be 35 ohms or so, and we're reading right around 42 ohms. Now initially I did not get that, but I bent that around a little bit, and as you can see, it's changing a little bit. So that's 42 ohms. We could probably live with that, but it was initially like 200 or 150 or something like that until I bent this. And you can go and you can squeeze these sometimes, but you risk damaging the fish paper in here, and these are notorious to short anyway. So okay, we're going to call that in halfway good, but not really, because I already know it's been bad. There's about 10 ohms or so. Then this one should be 200, and we're looking at 350, so we could probably squeeze that. Look how it changes with pressure. 275, that's out of range, out of tolerance anyway. But you can see how just manipulating these will cause these things to change quite a bit. So we're going to use a trick that my buddy Michael, leave the Candohm in place for legacy. For someone in the future will see, hey, this is a Candohm, that's what it's supposed to be. So we're going to take and we're going to build one, and I'm hoping to be able to come right up here and mount it right up under that. Use this lug here to mount the ground in, and then use that terminal for our Candohm. Let's take a look at the Candohm in this circuit. It's a 3-section. One of them is 202 ohms, one of them is 8 ohms, and the other one is 35 ohms. One end is grounded, the other end goes to the center tap. So this is basically giving a negative bias to various grids across the tubes. So in order to determine the wattages of these, we have to determine the current going through these. So sometimes you have to do a little detective work, and I'll show you how I do it. Sometimes they'll list the voltage drops or the voltage here and here and here, and so from that you can determine the voltage drops. And by using the voltage drop and the resistance, you can determine the current, and by determining the current and the resistance, you can determine the wattage of each resistor. The Candohm, let's go over and look at the Candohm itself. It's basically a wire wound resistor in this metal can. These are nickel plated tabs And from, let's say from this one, this is the ground. You can see where it's grounded to the, I don't know if you can see it or not. I can. That wire may be in the way. But you can see this one is grounded to the chassis. So this is the ground end of it. And then these tabs are crimped on to the wire wound resistors at different point so that it has a certain amount of resistance. Okay. Now these are rated usually watts per inch, and the serial number usually tells you what that is. Now you can get by with smaller wattages for a Candohm because it's connected and heat sink to the chassis, and that was what was unique about it. It was they riveted that in and had a quick connection, and they had like 3 resistors all of a sudden in just one thing. Now, like I said, those are crimped together, crimped, and sometimes you can take and you can crimp these and make because during the heating, expansion and cooling, corrosion, these connections down in here get bad, and so they become unreliable. Also, there is a material that's insulating this resistor and these tabs from the metal outside, and it's called fish paper. It's an insulator. That's all it is, a dielectric and insulator, so that so these tabs don't short out to ground. Now sometimes that material breaks down, and due to either the resistor overheating and it burns a hole in the paper or what have you, and then the resistor shorts. I believe Martin from Fibber's Closet, I think he had a good example of it in his last radio, where it had shorted, and I think it took some components out, and maybe even his transformer, or the prior transformer anyway. So anyway, these fail and they're unreliable, so most people just go ahead and take them out right off the bat, and that's okay. So let's take a look here at how we can determine. So we need to know the voltage drop from this point to this point. Of course, this is chassis ground, and then this goes to the negative side of number 45, I'm sorry, and that's one we just rebuilt a few minutes ago. Probably on another video, you probably won't see that for a while. And then the other end of it goes, if I can find it on here, goes to the negative of number 45 capacitor, but it also goes over here to the center tap. So this is the most negative part, and so this, like I said, gives negative bias to various tubes. All along, comes up and goes over here, and then goes up to the grids. So how do we determine the voltage drop across this resistor here? So let's take a look at this particular chart, and if you'll notice, this particular capacitor, this is the C45, and this is isolated from ground, and this one is, if you read across the terminals, reach 330 volts DC. Okay? Now all the rest of these voltages are measured from the socket contacts to the chassis, or the chassis ground. Okay? So let's go down to the rectifier on this particular heater pin, and it shows it to be reading 315 volts. Okay? Remember those numbers. Now on the rectifier, which would be this point right here, there's the rectifier, at this point right here, and the top part of that C45 to chassis ground is going to be 315 volts. Now if you go over to this point and this point, which is the negative side of that C45, which is isolated from chassis ground, and measure it, you will read from this point to this point 330 volts. So the difference from measuring it from the ground to here is 315. 315. And from here to here is 330. So that makes the voltage drop across this series of resistors 15 volts. So now we know 202 ohms, 8 ohms, and 35 is 245 ohms. Let's look at that on the Sky Carl sanctioned whiteboard. The formula we're going to use is the current is equal to the voltage divided by the resistance. We said the voltage drop across all three of these were 15 volts, and the total resistance is 245 ohms, and that equals to about 61 milliamps. So what we'll do is let's determine the voltage drop across the 202 ohm resistor, and from that we'll determine the wattage. Let's determine the voltage drop across the 202 ohm resistor. Use the formula E equals IR. We already determined that about 61 milliamps is the current through those resistors. Now there will be variance in this due to the very variable currents going to each one of the tubes, but it being a grid circuit, there's minimal. If you've got a lot of current going to your grid, then you've got more problems than this. So it's going to be rough. It's not 100% of all the current, but if this is the only voltage divider and none of the drops are going off of it, this is going to be really, really close, at least for determining the current and the wattage. So we take the current of 61 milliamps, multiply it, current times resistance times the 202 ohms, and that'll equal a voltage drop from this point to this point of 12.36 volts. Now, 12.36 volts. So to determine the wattage going through that resistor, the power is equal to the voltage, or the current, times the voltage. So P equals 0.0612 times 12.36 volts, and that equals to 0.757 watts, or 3/4 of a watt. And as we've said in the past, you do either anywhere from 2 to 5 times the a fudge factor to be overly cautious, because you're now standing in not really ambient air, because the resistors are not heat sinked to the chassis, but that circuit shouldn't pull more than 3/4 of an amp through that one resistor. So I'm going to use about 2 watt. I got 2 watt resistors over here in the box, so I'm going to use a 2 watt resistor on that. Now some people will just put 5 watts, 10 watts all the way across there and call it good. There's nothing wrong with that if you've got the space, if you've got the resistors, or you got the money, because a 10 watt resistor is more expensive than a 2 watt resistor. I mean, it's just, but I'm comfortable that the 2 watt will work for that particular one. So let's recalculate now for the 8 ohm resistor. Okay, we'll use the same current, multiply it times the 8 ohms. We get a voltage drop of about 1/2 volt. Okay, so we just insert it back in. P equals IE, current times 0.49, 0.5, or what have you, and we're looking at 0.029 watts. A 1/4 watt or a 1/2 watt is going to work fine there. So we could use a 1/2 watt resistor, and that's usually in everybody's box. Okay, I'm going to use a 2 watt. I'm going to use two. I bought a bunch of 2 watters, so I'm going to use 2 watts all the way across there. This is going to be the highest one. So as long as this one's above 2 to 3 times, I feel good. And this one's going to be more than that. So let's look at the 35 and see. Okay, we use the same current times 35 ohms. We have a voltage drop of 2.14 volts. Now our power rating for that resistor, P equals IE, is 0.0612 times 2.14 volts, and that equals to 0.13 or 0.131 watts. So a 1/4 watt or a 1/2 watt will work. Will work fine on that. And so we look right here. This is the voltage drop across. You said in the beginning, we said we had a voltage. If we put our meter right here, we're going to show 15 volts or so. So, and if we were to put the meter here, the voltage drop from here to here is going to be 12.36. The voltage drop across that 8 ohm resistor is 0.49. And then the voltage drop across the 35 ohm resistor is 2.14. So if we put the meter to ground and we put the meter here, we're going to read right around a little over 2.14 volts. And then if we take and move the meter to here, we're going to see roughly 2.63 volts from ground to here. Then if we put it right here, we should be pretty close to 15 volts total. So that's the voltage drop across that 202 ohms. This is the voltage drop across that resistor, and that is the voltage drop on that resistor. I've built this replacement. As you can see, this is the ground end, and we're going to put that under that bolt on that block capacitor for ground. So this end should be around 35 ohms or so. Remember, we used a 33 ohm resistor. So let's check this from here to here. We're reading right at 33 ohms or so. So the next section, remember we put 2 15s in parallel, so we're going to have somewhere between 7.5 and 8. And in this case, we've got right at 8 ohms. So there, it's dropping a little bit, 7.8, so that's good. And then the last section should be, it was supposed to be 202, so I'll put a 200 ohm resistor in, and we have right at 200 ohms. So I think that's close enough. I used 2 watt resistors. Remember that this 200 ohm resistor, we calculated to be about 3/4 watt, and so I'm using the 2. So that's at least 2 1/4 times the amount, and I think it'll be fine. And when we bring this up later on, we will check the voltages across this. So I hope you learned something from this exercise, and I appreciate it. And if you liked it, hit subscribe, hit like, and share my videos. And this week I've gotten about 4 subscribers from you guys just liking the videos and sharing them. So I appreciate that. I really do. Got a lot of good comments and a lot of good feedback, and we've got plenty more video to go. I've got I thought I would just make this video to show the Candohm resistor, because there's a lot of people, it's a mystery to them, but you can see that with a little bit of work you can work through the situation and figure it out. It doesn't have to be a mystery. It doesn't have to be something you dread. So I'm Larry from the hills of Tennessee. Thanks for watching.